In this video, I'm going to go through 2D physics. The scene manager also plays a part in the physics, as you have to set have physics to true in the properties window of the scene manager to make the physics work. Allow sleeping allows the game to sleep when it is not being used, and setting gravity X and gravity Y helps control the physics. You can pause the physics by setting update enabled to false, and you can find all these headings in the property window here. The falling animation on the right is made from 3 box sprites and a ground box sprite. The 3 boxes that will fall each have a rigid body child, which you can create by right-clicking on the sprite and selecting Add Object, GL, Physics 2D, Rigid Body 2D. It should be noted that you can only create a rigid body as a child of a sprite or spriter, itself a child of an object. Then your collision has to be a child of your rigid body. You can have many collision items as they all get drawn together as a physical object. The rigid body can be left empty and can rely on the collision types underneath it. To create a collision, you need to right-click on your rigid body and select Add Object, GL, Physics 2D and either Collision Box 2D, Collision Circle 2D or Collision Edge 2D. For a collision box, you can set its size, center. If it's angled, if it's a child, angle 0 will mean it is at the same angle as the parent. If you change the angle of the parent object, your collision box will change to match. Its density, the friction it has with other objects, and its restitution, which is its bounciness in the properties window. You can set the gravity of your sprite in the properties window of the rigid body, with one being the same scale as normal gravity. You can also set things such as inertia, mass, and the center of your object. You can also have callbacks on your rigid body, such as when it begins and ends contact with another object. For the ground box in the example, the rigid body type is set to static, as it does not move, but there are 2 other options which are dynamic, which means they can move, and kinetic, where only velocity is considered. You can set callbacks for rigid body components under the Events heading in the Properties window by setting the onBeginContact and onEndContact to onRigidBody2D_1 begin contact and onRigidBody2D_1 end contact. You can update any text you have in your project to link to the movement of your objects, like so, in Visual Studio. This means you can list all connected objects to the rigid body and output the text here as well. The text won't update in the designer window as the code isn't behind it, but it will tell you what the box is connected to, and in the example on the right, it is not only connected to the ground box but also to the 3 other sprites. You can also add in an on-click to the sprite components. When you click on it, you can apply a force to the box to make it bounce. The other type of motions you can apply physics to is the example on the left, where the box can bounce. This example includes 3 boxes. The lower 2 boxes are static, with the lowest box being the ground, and the bouncing box has a dynamic body type. The bouncing box has an increased restitution, so it bounces more, going above the second static box when it bounces, as you can see in the example. A trigger has also been created for this example, which is in the middle box. The trigger is static and is set to true in the properties window of the collision box child of the trigger object, like so. The trigger object being set to static means it does not stop or affect other objects in any way. The only reason you have it is so you can check the events. In the example, when the dynamic box goes through the trigger box, the text will flash to show it's been hit. This is useful so you can monitor and tweak your physics and say when you want to touch it and when it is hit. If you have set a high restitution, you will see your object bounce higher and higher. Whenever a rigid body or collision object is selected, it will then highlight the actual physics aspect in an alpha in the designer window. This is usually much larger than the size of the sprite and encompasses everything affected by the physics. If you have a complicated sprite, you could match the object itself, but you can also have these objects affecting other objects beyond the visible aspect the sprite is attached to. You can check your physics both in Visual Studio and MobileMill. Pressing the play button at the top of the designer window will run the animations in MobileMill, and pressing stop will reset the animations and reset the designer window. This means you can test the physics multiple times and make sure it works the way you want it to before having to open it up in Visual Studio. In Visual Studio you can run the debugger so you can interact with the physics by clicking on the trigger object to check their bounce, etc. And that's it. Thank you.